Professor Barrett here with video 1 from Lab15. I've downloaded the project, unzipped it, and opened it, and that's what we're looking at right now. This project is going to demonstrate recursion, which is opposed to iteration. Iteration is like a for loop, while loop, etc. Recursion is a function calling itself until it's done, until something is done. The explanation is excellent in the chapter 15 of your textbook, far better than I could do in the time period of a video like this. We're going to do the Tower of Hanoi, which is explained on page 1063. It's a game with 3 pegs and discs that go on the pegs. You move them from one peg to the next. Following those rules, we're going to use recursion to solve a puzzle. So if I run the project as it's currently written, we've got user input where the user enters a number, and then they click the go, and then the move of the disks, disk 1 to peg 3, that sort of thing. That will be listed in the big list box here. So let's go ahead and jump down, capture the button click. I'm down here right in front of the case, and typing very quickly. I grab the button, make sure it's the correct button. We'll need 2 variables. We'll need a variable for user input, and then we're going to convert that to a number because that number is going to be our iteration count. And we do that by getting the user input. The edit control is set to only allow digits, so that should work fine. And this first set is to empty the list box. So if this is the second or third time we've clicked the go button, it doesn't stack up. After we get the user input, we convert it to an integer, and that's where we're at right now, is we've got ourselves a good integer. I'm going to use exception handling to set the range. So with a try and catch, catch, CTH, there we go. I'm going to look at the input and see if it's too high or too low, and send an error message and go about. Okay, so the first try then should actually be, we could put it over the entire input if we wanted, but you know, actually, just in case something goes wrong with, I'm going to move it up here. Yeah, I'm just going to move it up here, what the heck, just in case something goes wrong. So there's my try around the entire input. Alright, so here I'm going to check. I'm going to say if the input's equal to 0, and since I've got the edit control set to only allow digits, I can't have a negative number because a dash is not a digit. I'm going to throw an exception here. And this exception is going to be a 0 exception. I need to go make those. Also, if I input is greater than, what's a reasonable number? 10 is probably a reasonable number. Too big, takes too long. It's a hard problem to solve, and it can take a really long time to go through a lot of checking. So I'm just going to make it a throw exception. Okay. So let's pop up to the top, Control Home, and I'll put it someplace where it's really obvious. You know what? I'll set it right up here at the top. What the heck? I'm going to make come on. And class too big. There. Class 0 and class too big, those are exception classes. Just data types so that 0 and too big work. What I forgot is that I have to actually put parentheses there to make those work properly. There we go. Now, the first one will catch 0. Inside parentheses, of course. The first one will catch 0, and the second catch will catch too big. Okay. Alright, I've got error messages sitting down here I'm going to use, so you don't have to wait for me to stumble through typing those. Input integer must be over 0. That's a good one. And this one, stacks larger than 10 will take too long. Okay, let me see if that works. It runs, that's good. If I say go, I should get an error message. Input must be greater than 0. I can't. Doesn't accept a dash, but if I put in 0, nope. Okay, so what if I put in a 1? It accepts a 1. What if I put in a 9? Accepts a 9. Let's put in a 10. Accepts a 10. Okay, so if I put in an 11, too big. Okay, looks like my exception handling works. Alright, let's come back to the next video where we'll start to solve this problem.